Okay, so this is the Chapter 5 test on page 345. I know it's late, but I figured, hey, if you're up studying, you might as well use this. So what I'm just going to do is go through most of them. Starting off with 1 and 2, we need to find the coordinates of the circumcenter of triangle ABC. Now, both of these I'm going to go through fairly quickly because it's not something that we did in class, nor something that you need to necessarily know how to do for the sake of the test. We did talk about this in class. We talked that the circumcenter of a right triangle is always going to be the midpoint of the hypotenuse. The reason for that is that the circumcenter is what occurs when you have all of the sides perpendicular bisectors lining up. So what we do is we sit there and we have 3, -1, 3, -8, and 2, -1. So we're going to take the two easiest sides, which are the two legs that make the right angle because they're horizontal and vertical. So when we do the perpendicular lines, we're going to end up with vertical and perpendicular lines. So we're going to go first with the right-hand side line. Find the midpoint. We go -8 plus 1 divided by 2, and that gives us -9/2 or -4.5. We then go 3 plus a -2 divided by 2. That gives us a positive 1/2. And then, so those are our two midpoints, and we just drop the perpendicular lines right through there, and that gives us a point of 1/2 -8. Because that is the point where both of those lines meet, it is also the point where all three of the lines meet. And so that's going to be our answer, not -8, -4.5. So the circumcenter there is 1/2 -4.5. Next, for number 2, we have this triangle, 0, 5, -4, 5, and -4, 3. Same exact process. We're looking for the circumcenter. We're going to find the midpoint of -4 and 0. That's -2. And then the midpoint of -4, 5, and -4, -3. Again, we know it's going to be -4 because the x doesn't change at all. So really what we're just looking for is the y differential. So we go 5 plus a -3 divided by 2. So that gives us 2/2 or 1. So we now have our two midpoints on the two legs. Perpendicular lines. Again, because we chose a horizontal and a vertical line, it's pretty straightforward. That gives us the point of -2, 1. And so that will be our circumcenter. Next, we go to ortho centers. Now, the ortho center is when we have is the altitudes. So again, we went over this in class. Whenever you have a right triangle, the ortho center is at the 90-degree angle. Okay. So here, where we have -1, -1, -1, 5, and -4, -1, the ortho center is going to be at -1, -1. Number 4, 3 points are 0, 0, 5, 0, and 5, 3. Again, we look at that, we go, hey, it's a right angle. It's a right triangle, therefore the ortho center is going to be on that 90-degree angle, or in this case, at 5, 0. Now we look at number 5. Number 5 says that identify the two statements that contradict each other. We have PQR as a right triangle, PQR is an obtuse triangle, and PQR is scaling. Now, a scaling triangle is simply a triangle that does not have any matching sides. Right triangles and obtuse triangles relate to the angles, the largest angle. Right triangle, largest angle is 90 degrees. Obtuse triangle, largest angle is over 90 degrees. So you cannot have both of those, so that's going to be 1 and 2. Now, on 6, we have 3 statements. We have that DOS is congruent to CAT. We have DOS and CAT are vertical. Now, if you remember what vertical lines are, they're that X, they're the bow tie angles. And we have DOS and CAT are adjacent angles. And adjacent angles, remember, are angles which are right next to each other. Vertical angles and adjacent angles are mutually exclusive, so you're going to end up with those two being contradictory. Okay, so this one's important. You guys need to know how to do this. This is a median problem. Never mind. Median problems later on. What we're going to do is we're going to go, this is a smallest to largest problem. So we have AB equals 9, BC equals 4.5, and AC equals 12. List the angles from smallest to largest. Now, if we remember the triangle side angle inequality theorem and the angle side inequality theorem, they basically say that when you have non-adjacent sides or non-adjacent angles in a triangle, that the sides opposite those angles are proportionate to the angle. So smallest side opposite smallest angle. Largest side opposite largest angle. So here, if we want to know what the smallest angle is, we look for the smallest side. That's 4.5. So that means A is our smallest angle. We then look for the next largest angle. That's our side. That's going to be 9. 9 is opposite C, so that gives us C as the final one, and last we have B. And B is opposite 12. So that is number 7. Now here we have point P is inside ABC and equidistant from all three sides. If ABC is 60, what is PBC? So what we're going to do is we're going to quick draw ABC. And we know that measure of angle ABC is 60. We have point P right there in the middle. So if P is equidistant from all sides, we need to know which one of those three, or which one of our four special points of concurrency is equal from all sides. And that, we know that the circumcenter is equal from all angles. The centroid is the balancing point, and the ortho center is just completely worthless. What we have is the ability or the need to use that last one, which is the in-center. The in-center is the point of concurrency, which is equidistant from all of the sides. Okay, so what we're doing now, there might be a little break, but basically, my computer died, so basically what we're looking at is that proportionally longest sides are opposite the largest angles in a single triangle. Okay, so that was number 7. Okay, so we were talking about number 8. So number 8, we have ABC, we have P as the point which is equidistant from all of the sides, which makes it the in-center. The in-center is the point of concurrency of all of the angle bisectors. You should be able to check your bell work from today and have that down. So we know that BP splits ABC in half. So we know that PBC has got to be 30 because ABC is 60. Next, what we want to do is we want to look at side shortest longest, number 9. So again, here we have, we're given 30 and 80 for R and S. We can figure out that 60 is T because we know, actually 70 is T, because we know that all three of them have to add up to 180. 80 plus 30 is 110. 180 minus 110 is 70. So what we do is we go in reverse order. We look at the shortest angle. That's 30, opposite the shortest side. Next is RS. Why? Because it's opposite the middle angle. And finally, we have 80 being the largest angle, which means that the largest side is opposite it. Okay, 10 extremely similar to that. We're going to draw our triangle. We're given 40 and 110. 40 and 110 add up to 150. 150 is 30 away from 180, so we know that the final one is 30. And yes, that is a 0, not a 6. Okay, so we now know that 30 is the smallest angle, which means that the side opposite the 30, KL, is going to be our shortest. Next, we have VM, because VM is opposite the next one. And finally, we have KM. KM is opposite the 110 degree angle, and therefore 110 is the largest angle, therefore it is opposite the largest side. Okay, now, number 11. Got to know how to do this. This is a centroid problem. So we draw our angle. How do we know it's a centroid problem? Because we look at what these segments are, okay? And the segments are medians. How do we know? We know they're medians because of the markings. We know that A to E is equal to E to B, which means that E is the midpoint. We know that F is the midpoint as well. The median is what connects C, a vertex, to the midpoint on the opposite side. So CE is a median, BF is a median, and so therefore P is our centroid, because P is the point of concurrency for medians. So we're given the fact that EP is 4, and we're asked to find PC. And we do that by realizing that the centroid is 2/3 of the way from the vertex to the midpoint on the opposite side. So we know that for EC, PC, which is vertex to centroid, is 2/3 of that distance. We know that EP is 1/3 of that distance. That's actually EC. I'll go back and I'll change it in a minute. So we know that EP equals 4, which means we can just plug 4 back in. So we end up with 4 equals 1/3 of EC. We multiply both sides by 3, and we get 12 equals EC. So we know that the entire median is 12. We know that EP is 4, so that leaves PC as 8. We could also do 12 times 2/3. That gives us 12 times 2 is 24, divided by 3 is 8. You'll get the same thing either way. Subtraction is a little bit easier. Got to know how to do this. Okay, next, 12, which is greater AD or DC. Now this is a little tricky because now you should be able to look at this and go, okay, AD or DC, which is bigger? Just look at the Hinge Theorem and go, well, AD is larger than AC because 90 is bigger than whatever Y is. But you actually have to justify that. We know that all three, that 90 plus Y plus 2X is going to equal 180 degrees. Now if we subtract that Y, or that 90 apart, we get 2X plus Y equals 90 degrees. Therefore, 90 has to be greater than Y, okay? We can also just do it more kind of logically, and we know that A plus B plus C equal 180 degrees. If Y is bigger than 90, then 90 plus something bigger than 90 adds up to over 180 degrees, so that can't be true. So what we do now have is the Hinge Theorem. We have DC is bigger than AD by the Hinge Theorem, because the Hinge Theorem is that if we have two sides to a triangle which are equal, and those are marked down, AB is congruent to BC, and we know that BD is part of both of those. So we have two sides of two triangles which are congruent, but the included side is not congruent. Then we know that the larger third side lies across from the larger angle, which means that because 90 is bigger than Y, that the third side of DBC is going to be larger than the third side of ABD. And those third sides are AD and DC, so we get DC is larger than AD. So now we're at 13. 13, we're looking at section 5.2, perpendicular and angle bisectors. If you remember, any point on the angle bisector is equidistant from both sides. So here we have an angle bisector. How do we know? Right there. It's breaking the angle up into two equal pieces. Therefore, it is an angle bisector. So any point along that line is going to be equidistant from the two sides. So if we have 5x minus 8 and 2x plus 13 as the distances from the sides to our point, then we can go ahead and just set those equal to each other. And once we do that, we can just solve for x, and we get x equals 7. Okay, now if you're asked to find how far it is from the 2 points, then you plug 7 back in, and you would get 27, regardless of which one you did. 14 is a side splitter theorem or a mid-segment theorem problem. We have, how do we know it's a mid-segment theorem problem? We look at the markings. The line which creates that little slope up, the little line up top, the 3x line. As you can see, it's connecting the two midpoints. Mid-segment theorem says that a mid-segment is parallel to and half the length of the opposite side. So we know that it's half the length, so we go 3x equals 5x plus 12 over 2. 3x is half the length of the other side of the parallel side. So we get rid of that 2 by multiplying by 2. So we have 6x equals 5x plus 12. We subtract 5x from both sides, and we get x equals 11. It's actually x equals 12. We could go back and double check that. 3 times 12 is 36. 5 times 12 is 60. Plus 12 is 72. 36 is half of 72, so that checks out. So now we're on to 15. Okay, 15, what can you conclude about the diagram on the right? Justify your answer. So here's the diagram. And so what we're really being asked to do is conclude that DE, we're supposed to understand that there are mid-segments here. Because D and E are both midpoints, you connect two midpoints, you get a mid-segment. Mid-segments are parallel to and half the length of the third side of the triangle. So we know that DE is parallel to BC and half the length. Okay, now 15 is a little tricky, or 16 is a little tricky. In ABC, BC is larger than BA. Okay? So what we need to do is sketch this out. Okay, so we have ABC, and we have a midpoint. The median, BD. Remember, a median goes from one distance, or one vertex, to the midpoint on the opposite side. Okay, so what we need to prove is to explain why BDC is obtuse. Why does B to D to C have to be over 90 degrees? Okay, now this is a little complex. So we know that BC, the length of BC is greater than the length of BA. Okay, we're given that. Which means that angle A, being opposite BC, is greater than angle C. Okay, and we also know that A plus B plus C equals 180 degrees. And then we also know that D plus C plus half of B equals 180 degrees. We know that because the median, actually, so we know that those three equal 100 degrees. And so we look at that. So what we want to do here is basically a little bit of an indirect proof, and using the converse of the Hinge Theorem. The Hinge Theorem, if you remember, says that the larger included angle is going to be opposite the longer third side. Here we have the opposite. So we know that with these two triangles, okay, so we have triangle with these two included the Hinge theorem. So it's going to include this side right here. So AD, because AD is equal to DC, right? Because these are a median. We also know that BD is part of both of them. And we know that the converse of the Hinge theorem says that the larger angle is going to be opposite the larger side. So we know from BC being larger than BA, okay, so we know that this right here is bigger than this right here, and therefore we know that that gives us A is bigger than C. In looking at the Hinge theorem, though, we have these two angles, and because BC is larger than BA, we know that this angle right here, D, has got to be, that we also know from the Hinge theorem that BDC is larger than BDA. I hope that makes sense. So that's the Hinge theorem. So we know that BDC is going to be larger than BDA. We also know that if we were to sit there and apply some indirect reasoning, we said if D is not obtuse, even if we said D is a right angle, that there just wouldn't be enough degrees to go around. Because if D is a right angle, then that would mean that BD is the perpendicular bisector of this triangle. And that would make it an isosceles triangle. We know it's not an isosceles triangle because BC is larger than BA. If D is less than 90 degrees, then that would mean that, so if we drew another quick small triangle here, let me just show you what I mean by this. If we went like this and we said that if this is D right here, and if this was less than 90 degrees right here, then that would make that more than 90 degrees. So that would make that an obtuse angle. And if that's an obtuse angle, then the Hinge theorem would say that AB is greater than BC. So because BC is greater than BA, using the Hinge theorem, we say it can't be acute, and it can't be 90 degrees, therefore it has to be obtuse. It's the only way that BC is larger than BA. Because if we're splitting 180 degrees into two angles, the larger one has to be an obtuse angle. Again, let me just wipe this clean and show you why that has to be so. I may be going a little bit overboard on this, but I think it's important to understand. So here we have triangle ABC. Because we're starting off with triangle ABC, we know that BC is a straight line. When we put the median right here and go, it's actually the median's BD, so we put the midpoint right here, and we draw the median, which goes from B to D. Okay? Now notice I drew it a little bit differently to show that it doesn't matter which way it goes. So we know that this angle right here, ADC, is 180 degrees. So if I label this as angle 1 and this is angle 2, we know that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay? So we also know then that they're not equal. How do we know they're not equal? Because we have BC being larger than BA. Okay, so gray line larger than orange line. Okay? Which means, according to the Hinge Theorem, that the measure of angle 2 is greater than the measure of angle 1. Okay, so if the measure of angle 2 is greater than the measure of angle 1, if we looked and said that M1 and M2 are equal, they'd both be 90. Okay, we know they're not equal. Why? Because we have this statement right here, which has to be true. So for 2 to be bigger than the other one, it has to be greater than 90, meaning it is obtuse. Hopefully that made sense. 17, 18, and 19, I'm not going to go into, just because I want you guys to be able to focus on what's going to be on the test, and those are not. I'm actually giving you a proof-free test. So tell you what, I will give you 2 extra credit points if you write thank you for the proof-free test on the test somewhere. If you have any other questions, feel free to email me, and I will see you guys tomorrow. Have a wonderful evening.